Hello students, my name is Rakesh Jha and I am with Nuclei Academy. So I am the faculty of mathematics. I will be dealing with IIT main and advanced. So we will start everything from the scratch. So in today's discussion, we are starting with the coordinate geometry. In coordinate geometry, I will firstly start with the basics of coordinate system. Then we will talk about the distance formula. We will talk about the section formula, both internal and external. And then finally, we will talk about the straight lines. And also we will talk about the slopes. So here, let's start now. In coordinate geometry, firstly we have to understand the coordinate system. So we know that we have a quadrant. So we have the x and y axis here. So here this is a coordinate system. We say rectangular axis we have. This is x dash, y dash, O being origin. So this is the first quadrant, and its range is between 0 to 90 degrees. So let it be theta. So the angle would be 0 less than theta less than 90 degree. Now if you talk about the second quadrant, let it be theta 1 first. Here theta 2 is second quadrant. Theta 2, it's less than 180 degree and greater than 90 degree. Now we have the third quadrant. In third quadrant, let it be theta 3, so it is less than 270 degree and greater than 180 degree. Now in a similar way, the fourth quadrant, this is the fourth quadrant. Theta 4, let it be theta 4 angle. So angle, it is less than 360 degree and it is greater than 270 degree. Okay. So we should talk about the sign convention also. So in the sign convention, this is the first quadrant. So both x and y axis positive, and here in this x negative, y positive. In this we have both x as well as y negative. Here x positive and y negative. So now we will talk about the same thing here. So in this coordinate system, x dash x, y dash, O origin 0. The coordinates of the origin is 0, 0. In this, let's talk about if any point, for an example, P is a point in the plane and its coordinates are x, y. What does this mean? It means that we have to draw the perpendicular from point P on x as well as y axis. And this perpendicular length basically gives the abscissa and the ordinates. So we know that this length from here to here, it is same like this length on y axis. So this is y coordinate and that is also known as ordinate. And this length from here to here is same as from origin to this length. So it is x length and this is called abscissa. So x coordinate is called abscissa and y coordinate is called ordinate. We are going to deal with the very basic concept first, that what is the distance formula. In coordinate system, if there are 2 points on a straight line, this is the line segment AB whereas A is suppose x1 comma y1 and B is x2 comma y2, then we know from our basic geometry in 10th grade also, like AB, distance AB will be root under x2 minus x1 whole square plus y2 minus y1 whole square. So in the next slide we are just going to prove this, how it is. So let's see all over again. So here we can see here x dash, y dash, O being origin. Here just take a straight line here, AB. The end point is AB, and let the coordinates of A and B is x1 comma y1, and the coordinates of B is x2 comma y2. So the same same formula that we knew in the previous slide, we are going to prove it. So how can we do it? For this, we can simply get the perpendiculars from the point A, this, and also from point B on x-axis. So here this is perpendicular. Now join this A to B in such a way that AC is perpendicular to BC. Okay, AC is perpendicular to BC. And now let's name them also. We have already ABC, so let it be D and it would be E only. Okay, so now what we can observe here, we are interested in finding the length of the distance between AC and BC. So AC is nothing but, it is DE, and DE can be written as OE minus OD. Perfect. And OD, it is OE minus OD. So OE is nothing but from the distance from here to here, and this is Y2. This would be X2 basically, because it is on the x-axis. So it would be X2 OE minus X1. So literally the length AC is X2 minus X1. Similarly, we can get the length of BC. So here BC can be written as BE minus CE. And in place of BE, what we can write? BE is the y coordinate, so we can write Y2 minus, in place of CE we can write AD, and now Y2 minus AD. AD is nothing but Y1. So BC length we got Y2 minus Y1, and AC length we got X2 minus X1. So this is Y2 minus Y1. Now let's talk about a right angle triangle ABC. So this is the right angle triangle ABC here. So A, B and C, wherein AC length is X2 minus X1 and BC length is Y2 minus Y1. So we have to find AB. So AB is equal to, using the Pythagoras theorem, we know that it is AC square plus BC square under root. Now AC is how much? X2 minus X1 whole square, and BC is Y2 minus Y1 whole square and under root AB. So this is how we are able to derive this basic formula, the distance formula. Now we shall be doing one question based on this. So let's take one question. Question number 1. find the distance between the point P. The coordinates of P are a cos alpha, comma a sin alpha, right? So it's a sin alpha, and another point, let it be Q, it's a cos beta, comma a sin beta. And we have the four options. So the options are 4 a sin alpha minus beta upon 2. B option is 2a sin alpha plus beta upon 2. C option is 2a sin alpha minus beta upon 2. And D option is 2a cos alpha minus beta upon 2. Okay, so this is very simple question. We have a blend of trigonometry that we can of course use it here. Of course we may need sine C minus sine D or cos C minus cos D. We will see it here. But what is the first perception comes to our mind? Like the basic formula we have to use, the PQ. So let's see the solution here. So here we have the points. Let's say this is the line segment P and Q. The coordinates of P is a cos alpha and a sin alpha. The coordinates of Q is a cos beta and a sin beta. So now you have to find PQ. PQ is a cos alpha minus a cos beta whole square plus a sin alpha minus a sin beta whole square under root. So we know very well that a minus b whole square is equal to b minus a whole square. So it hardly make any difference whether you take x1 minus x2 or x2 minus x1 whole square. So here if you want to expand it, our next step would be here. A square can be taken common, so you are here left with a square, and then it would be cos alpha minus cos beta whole square. Again a square is taken common, so it would be sin alpha minus sin beta whole square. Here we are going to use the property cos alpha minus cos beta and also sin alpha minus sin beta. So let's see here. So PQ distance would be root under a square, and here we have cos alpha minus cos beta, that we know 2 sin alpha plus beta upon 2 and sin beta minus alpha upon 2 whole square, and then again we have a square and then sin alpha minus sin beta. If we could see here sin alpha minus sin beta, it would be 2 cos alpha plus beta upon 2 sin alpha minus beta upon 2 whole square. So now if you take a common, basically we can see here that 2 can be taken common, a square can be taken common, and here sin alpha minus beta can also be taken common. Square is there, so firstly open the square here. So it would be a square and then multiply 4 sine square alpha plus beta upon 2, and here again sine square. Once a square is there, so we know the formula sine minus theta is equal to minus sine theta. But if you go for sine square minus theta, then it would be minus sine theta square, and it makes sine square theta only. So it doesn't make any difference. The formula that we have used here is cos C minus cos D, and that is equal to 2 sine C plus D upon 2 sine D minus C upon 2. And the another formula that we used is sine C minus sine D, that is equal to 2 cos C plus D upon 2, and then sine C minus D upon 2. So if you compare it, we can write this portion without any problem. Sine square alpha minus beta upon 2 plus a square times 4 cos square alpha plus beta upon 2 and sine square alpha minus beta upon 2. Okay, so in the next step, we can take common, and the common part will be a square, then 4, and then also sine square alpha minus beta upon 2. So what do we observe here? A squared and 4, so it would be 2a, because this portion 4a square and this portion 4a square, if you take it common, then it is outside the root, it would be 2a, right? And now we see this portion sine square alpha minus beta upon 2 and sine square alpha minus beta by 2. This can also be taken common. So if we take out from the square root, then it would be sine alpha minus beta upon 2. Okay, and here within square, this is the one portion outside the square root, and in the square root, what will be here now? Sine square alpha plus beta upon 2 plus cos square alpha plus beta upon 2. Okay, so what do we observe? The basic formula sine square theta plus cos square theta is equal to 1. Sine square theta plus cos square theta is equal to 1. So here the entire portion, this portion will be 1. So our end result is 2a sine alpha minus beta upon 2. So this is going to be the C option here. Let's see. Here, C option, 2a sine alpha minus beta upon 2. So this is the answer we are getting for this question. 2a sine alpha minus beta upon 2. So what we have observed here, even at the 10th grade, we have done the distance formula, and even the derivation is there in 10th grade. But here when we talk about IIT JEE, then it's altogether a different ball game, wherein all the chapters are mixed up together. Here we have seen the application of trigonometry in coordinate geometry. So these kind of questions will be there every time when we are dealing with IIT JEE questions. So my approach would be to start from the basic, very basic. I will go step by step, and then finally we will prove the concepts, theorems, and then we will take PYQs, previous year questions asked in the last 5 years. Dear students, now thank you so much, and we will do the next topic in the next session. So there we will talk about the section formula. We will talk about both internal and external section formula, and we will also take some important questions asked in previous year IIT JEE. Thank you so much.